be 4 projects presented that are you can see here in the first slide. So EVC 1000, 1000 kilometers plus, Evolver, and TEL. These projects, they all nearly started 2 years ago, and so they all being financed by the same topic, LCGV 1 2018, and they will complete their activities approximately pretty much in 1 year time for TEL and EVC 1000, and pretty much for 1 year and a half time for 1000 kilometers plus and Evolver. So we can say that what they will show today is pretty much the midterm results of this project. But what do this project wants to achieve? But you will see that this project concentrates on the development of integrated electric and electronic architectures for including some high voltage capabilities for some of the projects, electric motors, brake-by-wire, and all components to achieve this goal. And you will see also the fact that some of these features are practically and effectively connected to the infrastructure, for instance, to increase and improve drivability functionalities. The overall goal is to achieve a cost reduction of 20%. This was the original requirement from the topic, and also to show that this development will enable a long distance trip between 700 and 1,000 kilometers, and this is why you see the number 1,000 in 2 of the names of the project, with not more than 60 to 90 minutes stop time for the recharge of the electric vehicle. So I like that this is a very practical achievement, that it will really demonstrate the possibility that the electric vehicles can have such a long distance trip without having the burden of the stopping time for recharge during the trip itself. I think I said what I wanted to say. I think now it's time for the project to see how they intend to and how they are to achieve these targets. So give the scene back to you, Michael. Thank you.
Now it should be better with the microphone on. Yeah, thank you, Luca. So we will directly start into the first presentation, which is the project EVC 1000. As mentioned, the first project with 1000 in the name. It is presented by Eric Armengaud. So let's see the video. Yeah, thank you for this presentations. First of all, I asked the speakers to come online now with camera and microphone so we can enter the Q&A session. And I've seen in the chat box some lively discussion already started, also independent of the project, established, which I like. But first, before we go to this open discussion, I'd like to address the questions dedicated to the projects. And we have some of them. And we started with the EVC 1000 project regarding the efficiency gain, if it's related to the two-wheel drive, or if it's possible also to I'll read it directly. Is a provided efficiency gain related to a two-wheel driven vehicle? Is there any interest to extend the concept to a four-wheel vehicle? So maybe this can be answered.
Sorry, can you please repeat the question? It's related to the possibility to use the component for two-wheel vehicles. Did I correctly understood?
Yes, it is the provided efficiency gain that you named related to a two-wheel driven vehicle.
Mm-hmm. So these efficiency gain have been computed according to the vehicle demonstrator that we do have available in our project, a four-wheel vehicle. So we know from our partner Elafe that similar evaluation are ongoing for light vehicle and two-wheel vehicle providing some advantages in performance as well, but I would need to have a more direct feedback with them to provide you a quantified answer for this effect. But yes, application to lighter vehicle is possible.
Okay, also interesting to know. I think the question was: is it about the two-wheel driven vehicles, or is it two-wheel drive?
Okay.
Front-wheel drive
Yes.
or rear-wheel drive?
Yes. It's a two-wheel drive. Yeah.
And can you imagine to extend this concept to four-wheel driven car?
Absolutely, yes. It is absolutely feasible. So here, some evaluation has been performed in this aspect. With respect to control strategy, torque vectoring, it's possible. Yes.
Okay. I have one question as well. You've mentioned the Inwheel motor. You're developing Inwheel motors for your concepts, and I wonder, does this affect the vehicle dynamics? So you're adding unsprung mass to the wheel. For the suspension engineer, it would be a to be provocative nightmare. But there are other advantages for sure. So, is there any compensation for the effects, or do you see any negative effects at all?
Yes. So here, this is a very good question, and this is the reason why we introduce our innovation not only as a mechanical component, but as a mix between mechanical component and advanced control strategy. So especially in terms of vehicle dynamics, a very tight control with the torque vectoring is very important to have and possibly even improve the vehicle dynamics. It's one aspect. Second aspect, the introduction of brake-by-wires and the introduction of active suspension is summarizing the merging, the convergence between electrified powertrain and electrified chassis is a very important aspect, together with the control strategy to really use all the degree of freedom that the vehicle and the advanced control do provide. So we see here. So through the smart combination of smart component and smart control strategy, much more degree of freedom and much more opportunity to improve even beyond the current solution.
Yeah, I see. So the chances are by far bigger than this only risk.
Yes, but for sure these risks need to be managed very carefully. This is absolutely true. Yes.
Okay. Then my last question to EVC 1000. You named you have an efficiency improvement of 10%. This is an overall number, as I understood it. What is the biggest share? What is the biggest part of those 10%? For example, is it a traction part or recuperation or suspension maybe?
For sure, the largest share will be the traction part with the Inwheel motor and the very tight control, through the dual inverter and the control strategy. So the local control strategy to control the Inwheel drive. Second important aspect, but with less impact for sure, is the advanced brake-by-wire and the capability to have a higher degree of recuperation.
Okay, thank you for that. So then, any more questions for the EVC 1000? I'm just checking. No, I can't see any anymore. Okay, then let's move on to the project 1000 kilometer plus. First one is here. Could you please provide more details on how you scale the inverters? Do you simply change the components or do you use scaling method that take into account the power range, the losses, etc.?
Okay, I think the scaling with us is we distinguish between 400 and 800 volt. We start with 140 kilowatts with one motor. So that means we scale up by the number of motors, by the number of axles. And the topic there is using, in comparison to IGBT, the silicon carbide. And to give you a little bit an understanding about this, with the standard, or let's put it this way, with the volume of 140 kilowatt, you can, if you use the traditional silicon, and in comparison with silicon carbide, you can reach 170 kilowatt in the same size and the same format. I hope this helps.
I think so. There's a second question going in the same direction. So how do you scale the inverter cooling system when you up-down scale the power range?
Oh, okay. Inverter cooling system, that's a very interesting question too. So that means we was been looking in the same power loss dissipation. So that means the 140 kilowatt on the standard size with silicon and 170 kilowatt with the silicon carbide. So we look in the same size of the cooling system to have both available. So, and this will help us easily to scale up. On the one hand side, the question is, what are the cost achievements? As you may know, silicon carbide at the moment is, there are much more costs involved for the module, for the power module, and therefore we will bring it in the mass market. That's the idea behind. So to benefit from the high efficiency and get the volumes and put it this way, the size of the axle. We look into the axle for the 800 volt, for the 400 volt to get it down and to get affordable cost. This was the main interest behind. You are right, not the efficiency on its own. It's the whole system which benefits from the silicon carbide, and then to make it scalable.
There's another question, very detailed, to your project, 1000 kilometer plus. What is the modulation frequency using silicon carbide converter? What about the related electromagnetic disturbance?
Electromagnetic disturbance is a matter of how we build. This is more or less because the cables become very short. And if you have seen the axle on the picture, we was been looking to get it as close as possible. And the other topic is how we use the blocking. And in this way, EMC is on the same level. So and this is something we are looking into the next months when we are preparing the driving. What is the real situation, not only on the bench, what is the situation also in the car? So we will give these questions in roughly 6 to 8 months.
Okay, so probably at the next conference then.
Yes, we hope so.
Another question for your project. Which type of cooling are you using, and how do you solve the pack and electronics heat up due to the fast charge scenarios?
Was another topic. So somebody knows the details behind. It's water cooling. So for sure, fast charging, especially with the 150 kilowatt, is still questionable. So that means we are looking in the battery. It's mainly a topic is the battery and fast charging above 120 and maybe also above more severe above 150 kilowatt. So this is now we are in after 18 months. So we are in the way to get the components together. So the system components. And this is something we will do in the next 2, 3, 4 months.
Okay. I'm just looking. I think it was last in the chat. Let's scroll down. Here's one question for you. No, that's part of the open discussion we are entering soon. I have one question. Going through your presentation, you mentioned one aim of your activities is standardization, so making common components independent from the brand. I think I've seen this also in other presentations, but you're the one I'm asking now. How far do you think we could go with this, let's say, standardized components without affecting the individual characters of the brands? I mean, do you fear a let's say, competition to the activities within the brands?
Yes, for sure. We have, because the big companies, the big tier ones, are on a level where the price becomes very competitive at the moment. Not at the moment, since roughly 1 year. So that means the market situation with COVID and the recovering in China gives us a lot of, how to say it, a little bit with precaution. So on the one hand side, on a worldwide scale, there are companies providing powertrains. The price is, put it in this way, going to a level of the material. And to get the advance in the thermo-electrical integration, to get the advances in the thermal management of the system, and how do we can go forward with further cost benefits. So in my understanding, or what we calculated, is that we need the benefit of silicon carbide. We need to go down on a level where silicon carbide is common and available in high volume. And you see what we get in terms of differences between 400 and 800 volt. What is the copper content? What is the conductivity content? There are also the passive elements, which will give us the related pressure and current and all the electrical parameters are directly related to the weight. So higher voltage is beneficial, and it will drive us to, I think, benefits to maybe 10 to 15% in the cost area. The thermal electrical will give us also between 5 to 8%. So the standardization is heavily driven by the performance we expect, the efficiency we expect, and this gives also the size. And there will be, for the next at least 10 years, a high competition to go further on the standardization. This is a big topic, or this will be a topic which will keep us busy for the next 10 years, is my opinion.
An interesting view. I would like to step further to the next project, to Sevolver, to Christoph, and ask him the same question about the standardization of components and let's say, how the market will develop between suppliers and OEMs, who is doing what in terms of components and developments.
Yeah, so we are tackling this brand independency more on the function base, and also with a brand independent cloud connection. So the virtual side of our project in the first place consists of OEM cloud, but that shall then communicate also with brand independent services in the virtual space that provide information about charging stations, about traffic and weather information. On the other hand, for sure, we have a major supplier integrated in our project, who also certainly aims at kind of let's say general applicability of his components for multiple OEMs. So that in a certain way together with the OEMs also brings in some, let's say brand independency, but also moves towards standardization, because certainly OEMs want to have a cheaper purchasing. So they will certainly push for, let's say, common interfaces, but it's walking on a thin line, because they certainly will also want to bring across the particular taste of their own brand. Yeah, so it's a pro and cons of this brand independency. It's a big chance to save costs in the components that you do not see. And it's a matter of the very calibration of the vehicle to make the difference between the different brands and models.
Yeah, as you
say. Yeah, it's a lot about software.
This is the new word, I think. This is software topic.
Yeah.
Which leads me to my next question to you. You have mentioned the connectivity of vehicles, artificial intelligence, machine learning, etc. As I'm not expert, so I'm curious to know who is really processing the calculation. If you have algorithms, if you have clever software, etc., is it placed somewhere locally in the cloud on a server, or is the vehicle itself calculating, or both?
Well, this was in the section where we pointed out to the, let's say, to forthcoming or future projects to address with the consortium, or with the partners from this consortium. As we can see, well, you already have, let's say, some parts of artificial intelligence, even on your smartphones, maybe, if you are willing to pay enough for it. So it's, let's say, the computational power, at least for limited applications of artificial intelligence, is available on rather small power consumption. But if you really go into deep learning, machine learning, then it takes more IT equipment that is more likely to happen somewhere in the cloud services. So the idea of our Sevolver project was to collect data from the way how the vehicles are actually used, feed them back to the OEM, who can then identify in which parts of the map is the vehicle, are the electric motors, is the battery actually operated, and the next generation of the vehicle can focus more on the very usage of this vehicle, and find some cost optimization potentials, and also maybe push the performance of the vehicle into ranges where it has reached its borderlines. That is certainly something that happens more in stationary IT equipment, indeed. Yes.
Yeah. Interesting word. The last question that I've noted, you said that the project saved between 2 to 5 years in terms of development time. So what does it mean in terms of Europe's technological level? Are we now ahead, or on the same level, or less behind the competitors?
Next question, please.
I think this is what we compare. If we look at the machinery, the integration, and all these topics, we are very competitive. So if you look at the powertrains, if you look at the performance, if you look at the use of materials in the propulsion system, also what we have as integration on the battery, this is very competitive, and that makes also the pricing of the components in this way, or the subsystem components. We are looking into the edge capability, edge cloud capability, and we need to get also the way to the connectivity of the mobility itself. So looking into connected shared mobility is something which we need to push. And I was very impressed about 2 years ago when I have seen somebody coming from north of Scotland with a trailer down to Landau. It's 1,000 miles one way. So, and I would feel a little bit pity that this was not a European car. So this was also some of the motivation to say, hey, 1,000 kilometer plus with a European car with a trailer, this must be possible. So I think we need to go into the challenge itself to see and to use our technologies we have to bring it in the market, to drive around and not to be too much concerned about something that we can do. So let's do it. And if we run the technologies in our applications, we have a lot of experience over 500 years. If you look back in the history of Europe, we can do. So, and we will also win this battle. This is just a matter of dedication. This is a matter, and if you look into the projects, the people is very convinced that they can do, so they will do. And future technologies is edge cloud connectivity, virtualization, getting more intelligence, automotive intelligence in the car. This is a long way to go through the certification to get non-deterministic systems approved. We need to take a look on the aviation. They are even more conservative than us. But there's a lot of interesting stuff which can be combined. We have the industries. Let's take what the best from each industry and the real-time environment on the edge applications. We have the robotics, we have the machinery, we have the things. So bring it together and run it. That's all.
Very promising. I like that. I think that's a correct attitude. Nothing else would be successful.
Yeah.
I've just checked the chat box. No new questions to Sevolva project. There was one question in order to the TEL project to Pietro. You mentioned the low energy consumption of 10.84. Is this a confirmed value?
Yes, this is a confirmed value in the WLTC cycle, but usually, as Jan already explained, we are addressing urban mobility. It is very rare that you cover the full WLTC cycle. You drive at much slower speed, and the real consumption of the vehicle is much lower than that. But we have a four-wheel drive, and the efficiency is also taken by the fact that we have MOSFET technology. We don't have power technology or ICBT technologies, which cannot guarantee the curves that I presented. So the efficiencies that we have in the low-speed urban cycle is not possible with other technologies. You have these efficiencies because we have four-wheel drive first, and second, because we use MOSFET technology, which have incredible efficiency. This is the reason why we have such high efficiency. It's not, of course, that the vehicles are also lighter than other cars, but these are M1 vehicles, by the way. These are M1 vehicles. The maximum speed, which is limited by us, by the way, is 120 kilometers per hour. So I confirm, even better than that, not just I confirm.
Christoph, go ahead.
That was my question, actually. So I noticed on your slide, I think you told even that your WLTP cycle was downscaled to 115 kph or something. Yeah. Yes. So indeed, driving slow is really beneficial, in particular for an electric car. because you immediately see the power consumption of increased speed in your state of charge. Did you downscale the entire cycle, or did you just cut the peak velocities?
The second part of the cycle, as it is written in the slide, the second part of the cycle, not
Okay.
the first one. But let me repeat. What we are really looking at is efficiency at low speed, which makes a big difference if you are driving in cities. Whatever kind of cars you have, whether it is a SUV or a smaller car, what you should look at is efficiency at low speed. And that's what it was possible thanks to the specific design that we asked as IFES to our partners. We want efficiency at low speed. We don't care about the peak efficiency. But at the same time, they also had very high efficiency as a peak efficiency. That's the point. And this is possible because the MOSFET, in this case, MOSFETs developed by Infineon, by the way, are tremendously efficient and tremendously thin, because you know that the current is passing transversely through the MOSFET, and the thickness is also an important aspect in getting efficiency. So they are developing tremendously thin chips, which allow this efficiency. But anyway, Dana, before they were, the name of the company was SME, has developed this stuff after years of development, after we pushed them addressing efficiency at low speed. And probably we were the only one asking for this at that time. Now people understand this, and they are all let's say, looking for high efficiency, let me repeat, at a slow speed.
There's to this topic an interesting question from Maurizio. Why is it worse for an EV than an ICE? Is actually the reverse given efficiency?
Wow, well, this is obvious now. They say an internal combustion engine has a peak efficiency at a certain RPM, and when you are far away from this RPM, the efficiency goes down and down. This is clear. So if you do not drive at that speed, the efficiency of the ICE is very low. This is not true for the electric motor. So the difference in between an electric motor and an internal combustion engine is particularly evident at low speed, where the internal combustion engine is particularly inefficient. You see the point?
Exactly. Yeah.
That's the point.
Fully agree. Yeah. So the lower the part load of your ICE, the worse the efficiency, indeed. Yeah. And there's nothing worse than going in first and second gear across the city. That makes your ICE a guzzler. Whereas, you can get very far with a better electric vehicle. Yeah. And as soon as you get to, let's say, speeds maybe in sixth gear on a stick shift engine, on a stick shift transmission to, let's say, 70, 80 kph, then you're running fine. Yeah. So you have a higher load on your ICE, better efficiency, and smooth driving also is an important point. Yeah. So whereas the electric vehicle can recuperate energy during braking, with the ICE, unless you have a hybrid, will not recuperate, and you have to engage the thermal brakes. But these are, let's say, this goes all without saying. Yeah.
I think we need to compete in reality. I just mentioned the story from this Scottish guy, and I asked him, how long did you need? And he said, not longer than with a combustion engine. So that means he drives on a good speed, and he compares it with the reality. And this is, in my opinion, what we have to do. We need to prove that electrical car, regardless what we use in terms and all these technical terms, it's usable, it's affordable, it's competitive. And then we know it's cleaner, it's this and this. But first of all, we need to show the people that it's what we have. We can compete with all the reality we have around us. And this means a certain speed on the highway, a certain speed with the trailer, a certain capability to be on time if you're on a business trip. And it means also a certain convenience with charging, fast charging. So fast charging is a topic where you give more range to your car. And if you realize it with 400 volt, 800 volt, with silicon carbide, with IGBT, doesn't matter. The customer is willing to pay a certain price and he expects a behavior which he is used to. So, and I think this is well understood. If you look also in Volkswagen, if you get your announcement, if you look in Daimler, they are without a compromise. They say we will deliver, and that's the point. So the technology and the technology behind. We even have a discussion, silicon carbide. We have 2 fractions in Infineon. So that means we will provide the highest quality to our customer at an affordable price. But it must be seen on a system level. That's, in my opinion, the topic. And we have to compare then with the reality. I think Michael can tell us something about his company, how they see it, what is their strategy, and to have a clear idea about it. Michael.
I will for sure not tell you, discuss about the Volkswagen strategy. But
Oh,
nice
sorry.
try.
Just a trial to get you on.
But what is public available information is very clear that we are really focusing on electric vehicles. ID3 has been launched, ID4 is coming, etc., etc. With a nice, let's say, very consequent approach. But at all, there are still some questions from the, let's say, general discussion. I would like to make the transition into the open parts. I know you've nicely described the system approach, that we have to have a bigger picture to see the overall, and which is in line with the questions that have been discussed between Ian and Pietro in the chat. So I want to summarize the question. The question was, how much of the people are really doing 1,000 kilometer trips, a part of the daily 20, 30, 40 kilometers, for example? So how much percentage is this use case? And deriving from that, will the user be willing to pay for the extra cost for the big battery, which they use 1 or 2 times a year? And another question was, how many stops are acceptable when on a long trip, on a long distance trip? So what is still accepted by the user? Is it 1 stop every hour, 1 stop every 3 hours, etc., etc.? So it's in general, what does the user want at the end? So maybe it would be interesting for the audience to get your vision or your estimation of what will be accepted by the market in the future.
Can I make a comment? Do you allow me to make a comment?
Yes.
Everybody understands climate change. Everybody wants to contribute. But when you touch their pocket, they say, why I should be the one that pays for everybody? So affordability is an extremely important aspect. Now, when talking about affordability, we have to make a very simple statement. Today, battery cells can be purchased even by an SME at $60 to $80 per kilowatt hour. This is one fact. It's not an impression, okay? $60 to $80 per kilowatt hour. Even an SME can buy this. Now, I have a question to all of you. How many times do you stop per week to fuel your car today? Once a week? Twice a week? But if you are asked to change their mind and charging every day because you are on the road, people don't like this. People don't like this. So we don't need, Jan is right, we don't need to ride to have a 1,000 kilometer range available. But the fact is that today we are used to that. If not 100, 600. You see, this is the point. You should not ask the people to change their mentality, to change their habits radically this way, just because electromobility is coming. Electromobility is coming, it should not cost more and should give more, not less. This is the point. This is the point. But cost is everything, we said. Today, battery cells cost much, much less than what we were used some years ago, even to SMEs. And so adding 10 kilowatt hour extra in a car, 10 kilowatt hour, is not such a big change, you see, in terms of cost. So I'm not saying 1,000 kilometers, but the 300 is really the limit, okay? So this is the point. Affordability, and please do not ask people to change their habits.
I think what we said is reality. On the other side, if you buy a new mobile phone and you pay a certain price, you expect it's better than what you have before. You trust in the technology development and you would like to have more functions. You would like to have more performance regardless you need it. I think you can get many examples around you if you ask the people why you buy this car. Do you ever drive 220 or 250 kilometers? They just buy it. So that means we have the luxury segment. We live in Europe to sell such cars. We need to be on track with that. We need to show it's possible to do. It's from early adopters, they're looking into, yes, I have for sure social benefits. I contribute to a greener world. By the end, we need to develop technologies which are capable to compete with the reality. And this is what we see now in the past 1 year in the decision of the big OEMs. So that means if you look what you provide, we have this. If you look at Daimler, if you look at BMW, if you look at the homepages, you see we will deliver. That's their commitment. And our task is to provide the technologies behind which are needed in 2 years, in 5 years, in 10 years. We need to develop a vision for this. And what we did in the past 10 years, and I showed this with my foils, we started 2008 with a very humble 30 kilowatt electrical motor. I was convinced 60 kilowatt is more than enough to drive every car on a certain speed. And with 3C car, 2 times 250 kilowatt, 500 kilowatt on one axle is something, yes, it's there. So that means 10 times more dense, 10 times better in performance at the acceptable cost and similar size. This is what we can do with technologies. That's the task for engineers. And this is the task for this kind of, we get funding, we develop, we invest. So there must something which comes out. So not to say it's maybe not or less, we need to compete in the reality.
Absolutely.
And maybe
Erik, your word?
Yeah, thank you very much. So 2 aspects. The first part is in terms of a customer acceptance. So here it is at the end the keyword. So most important aspect. So what will be here the expectation of the customer, possibly towards more mission-based electromobility, and this is something which we need to take into account. The second thing is in terms of changing the habits. So for sure, as a technology push, it's very difficult to change the habit of the customer. Parallel to that, we see a very strong trend toward the digitalization in the technology. So we already see that in the different programs, but digitalization in the social life as well, in the daily life as well. And here it is expected. So we already seen that, and the example of a mobile phone is a very good example. We used to phone with a mobile phone. Now we are using to do everything else but except phoning with a mobile phone. And this expectation in terms of a digitalization of the life, of the daily life, of the mobility, this is a trend we are into. And this will be the question: what will be here the expectation of the customer, and so possibly the constraint of the changing in their way of moving that will take place in the next 2, 5, or 10 years, and that we need to prepare today.
Yeah.
Thank you.
Yeah, Christoph?
I think it's also, when talking about changing the habits, it's a matter of the experience. So if you let people drive, let's say a BMW i3 with 160 or maybe 200 or 250 kilometers range, for a few days before they actually go and order a car, they will find that, man, this is just sufficient for myself. Yeah. So I can handle like 80% of my daily business, or maybe 90% of my daily business, just with this range, without even thinking about to charge the vehicle, provided they have a place to charge the vehicle maybe in the evening every second day or so. But you can really do that. And this is also a way maybe to bring people to reason, not asking for these battery monsters, but look for a reasonably sized car that they can use for daily business. And what I found particularly interesting was the fact. The project yesterday presented by Angelos about the L category vehicles that were part of this demonstration project, put in different places where people really went for it in the cities instead of public transport. And they had a really good pickup of these very small-sized electric vehicles and didn't want to get rid of that afterwards.
Fully agree. We have 4 minutes left. So I would like to kind of go towards the end of the session. First of all, as an example, my habits, we are talking about habits, changing the habits, etc. Me as a customer, for example, I want to keep a long distance capability of the car, because my car is my second home. And if I go to the holiday to Norway in the never, there's for sure no charging station where I need to go. I rely on my current vehicles, and this needs to be replaced fully with no compromises. Before that, personally, in my use cases, I'm not happy to change. But this is individual. So that's why I want to close it by asking all of you individually to answer the following question. So which level of range and charging time do you personally need to decide to buy a battery electric vehicle? You personally, as a private customer. So starting with Rainer.
No compromise compared with the diesel.
Okay, very clear. So Erik?
So much flexible, because I would like to have the vehicle which is adapted to my today needs. And if I need to have access to different vehicle to address different needs, and if there is a business model for that, happy to use this. I don't need to own a vehicle, I need to use a mobility solution.
Okay, so Christoph.
Yeah, I kind of agree with Erik. So coming from Aachen, just for my daily business, an Ego Life would be fine, or something with a very small battery, I have to say. But every second week, I have to bring a lot of garbage from my garden, and then I certainly need a big trunk. If this could be rented at affordable cost, yes, I would certainly go for that very small battery electric vehicle. Or if I have the choice hosting 2 cars, then yeah, there would be 2 of them, but the bigger one rarely used, and that might be a plug-in hybrid then.
Okay, that's a nice compromise. So Pietro, what is your preference?
Well, first, I can find some compromise on range and cost, but I will never find a compromise on safety. Okay, this is first issue. I was addressing the L category myself at the very beginning when I said, as far as the cities are as they are, the L category in Europe doesn't work. You can buy an L category vehicle for your mother-in-law, but you will not buy it for your daughter, I'm always saying. That's the point. The other aspect is in terms of performance. We are facing a 50% compound annual increase in the selling of e-bikes. Okay, and there will be, of course, because of the new regulation, it is coming also speed pedelec will increase dramatically from 1% to 9%, perhaps 10% of the market, okay? But you have better performance, not lower performance, okay? That's the point. You go faster, and you now have an alternative to the cars in the city. This is the reason. You have better performance, much higher price, but you have better performance. So you see the point? Now the issue is, what can we do for safety in the bike? In the bike environment. This is another big issue. Okay?
Exactly. It's another big issue. So the answer to the question, what is your preference buying a BEV? What is it?
No, I will buy a nice car because we are already ready to a small vehicles. In my presentation, I was provoking the European Commission.
Okay.
Why you don't buy 20 at a Chinese price, and then you provoke the overall environment? They will not do it, of course, but as a provocation, I am focused on this kind of cars because I believe on that. No, I'm not buying BMW, very nice car, nothing to say, but this is not my target. That's the point.
Okay, yeah, thank you very much. It was a very, very fantastic discussion, very lively, very interesting, with good points and arguments, and very, very widespread, I would say. So you can see there's no clear trend. So this is the end of the session. Thank you very much to the speakers, to Luca, who's already in the Zoom session. So everybody is encouraged to go back to the lobby and visit other sessions, visit the online exhibition, and also make contacts. Start connecting with other people via the chat function, which is here also possible via digital functions. So thank you very much, and enjoy the conference.
Thank you.
Bye-bye.
Thank you. Excellent moderation. Thanks, Michael.
Thank you.